Hi, I'm Paul Brodie, and we're in my shop again. There's a man behind the camera, and as you know, his name is Mitch. He does a great job. This is 1 year of us, myself and Mitch, making these YouTube videos on this channel. So thank you for watching, subscribing, liking. We appreciate it a lot. I was going to talk about, I have new signs. You've seen this sign. I have making stuff, and I also got safety third, and I want to talk about safety a little bit because there's been some comments. Now I know that you might think I kind of joke around with safety third, and I even have a shirt. A friend, Scott, he made me a safety third shirt, but we are serious about safety, and a lot of the comments have been about my use of gloves or my lack of gloves. So it hinges on TIG welding, the bandsaw, and the drill press, because sometimes I use gloves and sometimes I don't use gloves. In the TIG welding, I know from experience that if I'm welding at low amperage, 45, 50, I don't have to wear gloves. I'm not going to get a burn. If I weld aluminum or heavy duty steel, I wear gloves all the time. So I realize I'm setting an example, so I will wear gloves in future when I TIG weld. Now on the bandsaw and the drill press, I think it's up to the operator and the situation, because I don't think you can say you always wear gloves or you never wear gloves. I think it depends on the situation. I had a comment from a viewer, and he said that his friend was working on a drill press. It sounded like a big drill press, and the glove got caught and he lost his thumb. I'm sorry to hear that. But also, when I was working on my small drill press, I was holding a piece of metal. It was an odd shape, had sharp edges, and the drill caught it and it spun it, and it hurt my fingers, but I had the gloves on, so I didn't bleed or anything. It just kind of stung. So I think it depends on the situation. I'm not going to tell you to wear gloves or not wear gloves, and I know I am setting an example, but I think there's individual cases. So I want you to be safe and think about each situation. That's what I got to say. Thank you. We're going to work on Aermacchi fork mods today, and we've got a whole table here of parts laid out, and I have a sheet here. This is all the mods. When I was building the race bike back in 2000, I had the beta forks off a motocross bike. Back then, motocross bikes had 6 inches of travel, and I wanted to go road racing. So I sent them down to Lindemann Engineering, and I talked to him on the phone. He says, yeah, and he talked really slow, and he says, yeah, we think we can do it. It'd be about $300. So I sent him down, and that's US dollars. So by the time I sent him down, paid postage back and forth, customs and all that, cost me $500 Canadian. So I raced it for a year, and then I took the fork apart because I wanted to know what he did. And what he did was not rocket science. There wasn't, I mean, yes, there was some modifications. You weld up some holes, you make some spaces, you shorten. That's all here. So if you're building a road racer with beta forks, this is going to be very useful to you. Now, there's not a lot of you doing that, but anyway, the information's there. So let's get going on the forks. I got 2 sets of forks here, basically. I got a set off of my friend Blair, and you can see here, this is the set that I had on the bike. I've got them polished up nicely. This is what they look like when you get them. They're really rough. And you see here, if you can zoom in here, Mitch, see all of the damage on the tubes? That's really hard to fix. That would be really expensive. So I got some much better tubes here. And we're going to put these tubes into this set of lower fork legs, and we're going to do some modifications. So that's the plan today. First thing to do is we're going to take these forks apart. I haven't had them apart. I don't know if they got oil in them or anything like that, but that's the first step. So we'll do that. See here, there's a drain plug, so I'm going to take that out. Ooh, a little tight. There we go. Oh, there's oil in there. Oh, look at that. There we go. So when this comes loose, the oil should flow out better. There we go. That's what I expected to happen. I didn't expect that huge surge. That's weird. That is not an Aramaki pot. What someone has done is they wanted more spring tension, and they put this thing in here. Interesting. There we go. There's a spring. I've got a 6mm Allen key is straight. I've been told that it helps if you hit this. And I've got my, let's see what happens here. Yeah, that comes out easy. And you've got two washers here. You've got a lock washer and you've got an aluminum, I think that's an aluminum washer, so it helps it to seal because that's a bit soft. And then this should pop off now. There we go. And that's the damper rod right there. So this piece here has to come off. It slides onto this because the damper rod comes out this way, out the top. So this has to come off, and what I did last time was to use a pair of pliers. I put a rag on there because I don't want to put marks in there unnecessarily. Oh, this one's tight. I guess I could put a bit of heat on there. That might work. A little bit of heat. What's happening here, hopefully, is the aluminum is going to expand at a faster rate than the steel. And even if it gets just a little bit bigger, hopefully it'll break loose. There we go. That's what's supposed to happen. Actually, that should, let me see. There we go. That just pops out like that. And then we'll take out the internals here. I'm going to choose all the best parts out of both forks, and then I'll build one fork. That's the plan. Sometimes these don't pop out so easy, so I need a socket. There we go. Use the socket as a slide hammer, just a very light slide hammer. And there's all the bits. So there you go, hollow tube. I always smile when someone says, I'm looking for a hollow tube or something like that. All tubes are hollow. In the top is the oil seals, and there's two. On this bike, it's a dirt bike. It's a Can-Am. It's off a Can-Am, which is a Canadian make. And there's two seals. I guess they did that because it's a dirt bike, but that's extra stiction. So it's not going to have two seals when it goes back together. It's just going to have one seal. I'm told there's a special tool that goes down and grabs, but I don't have that. I just have my old screwdriver. So I'm going to see how that works. Although I did make up a piece of aluminum here so that I'm not going to hurt this edge here. So we'll see what happens. Sometimes these are hard to get out. You have to get under it and then pry it. that last fork, it was hard to get out, because what happens is the seals, I'll show you in a moment, these seals have an outside made of steel, and on a dirt bike there's always moisture, and the steel and the aluminum, it gets corroded. So the first seal is always harder to take out than the second seal because it's got the corrosion. It just wants to break. Okay, we'll take that out. Okay, this is a brand new seal which you buy today, and it's basically rubber. It's a hard rubber on the outside. This is the one that came out of the other fork. Can you see how it's encased in thin steel? So there's nothing, as you take it out, that's how it goes in. There's nothing really you can grab onto there because it's all inside, it's all rubber, and this gets corroded. So in terms of service, it's not a good design. What I've done is I've weakened the wall, and maybe I can hit it in with a punch. Yeah, it's loose. There we go. Okay, it came out. So now we just have to do the second one. Maybe the second one will be easier. This one's down farther. It's harder to hit at an angle. On the top one, I can hit it at an angle and drive it in. This one's more difficult. I got this tool. See how it's got an angle? I sharpened it at an angle years ago, and maybe that'll help. Help to pull it away from the wall. Oh yeah. It's coming out. Having to use all my arsenal here. There we go. It's coming out. So that's what it looks like after all that. Hitting that, popping it out. What a lot of work. But if you look inside, that's where I was hitting. I didn't do any damage, so that's good. I just have to take emery cloth and clean that all out. It's corroded, that's what it is. Okay, here is the top caps, and these you can see how they just mangled, and then someone did something in here. They got some kind of a grinder in here. So I just have to pick the best two. I actually weighed them. These ones weigh a few grams less, so we're going to use these ones. And it's an odd size. It's 25 millimeters, and I don't have a socket that size. We're going to cut these down so everything is nice. We're going to make it 19 millimeters in the mill on the rotary table. Have to get the size right. So we're going to have a cut. We're going to take a cut from one side and then spin this 180 and take another cut, measure it, and then I'll know how much to move the table in. And we have to take off 213 thou. So half of that is 106 about. So we're going to move in the table 106 thou. So it's a hex, so every 60 degrees. It fits. That's good. It's not much slop. Much nicer. And after that gets faced off, I'll also put a little chamfer, because the chamfer is going to go on the edge there. That also makes it look very nice. It's the little details that count. So what I talked about, I want to put a slight angle, just a slight angle there. It just makes that look much nicer. And so the cut comes down to the middle there. You don't want to come, well, maybe a touch more, but you don't want to come that much more. It's just a nice little touch. There, see, can you see that little bit? It comes around there, and it came in just a little bit from there. That looks good. So I'll file that now. So I'm curving around, and I'll also take a little bit off the top of the hex, just so it's not quite so sharp. Just a little bit. I got a pretty sharp file too, so if I press too hard, I'll take too much off. We got a high-speed steel tool bit here. It's not carbide, but we're only cutting aluminum. After all that, that's what they look like. I think they look fine. I wanted to show you what a stock Aramaki fork looks like, and this is basically a stock fork. So if I take one of the tubes that I'm using, I'll lock it. It's 35 millimeters. Look at the difference. This is a 30 millimeter fork, so it'll flex under braking and cornering and things like that. So this is much better for a road racing application. Our next job here is to shorten these fork tubes. So if you look at the ends, this one here is smooth inside. It's got a circlip groove and it's got a step. This one here has a thread. So which one's going to be easier to shorten? It's going to be this end here. So that's the end we're going to shorten. This is hard chrome. And there's two different kinds of chrome, if you didn't know. Actually, maybe there's even more, I don't know. But I know about hard chrome and I know about ornamental chrome. That's what a car bumper used to be, ornamental chrome. It's soft, it shines, but it's soft. Hard chrome is very, very hard so that it wears very well. So you want hard chrome on a fork blade, so on a fork tube. So I'm going to show you two different ways of shortening this up. On the first one, we're going to use a handheld chop saw. And on the second one, we're going to go to the lathe. I'm going to grind off the chrome using my belt sander. I'm going to mark the space, and then it's going to get separated or cut in the bandsaw. So we're going to use a couple different ways just so that you can see a different way. So the measurement, it's going to be 544. We're measuring from this end here, so you can see how much shorter it's going to be. That's the final length. So we're going to make it a little bit longer, and then in the lathe we have to do that. It's a radius, I guess you'd call it. Masking tape is handy for all sorts of stuff. So on this one here, I'll use the cutoff wheel, and I'll cut a little bit longer than the masking tape. And on the other one, I'll put masking tape, and I'll put masking tape over here, and I'll grind off the chrome with my belt sander. That's my sketch there. That's what's going to happen. You can see that there's a shoulder here. I got to do the shoulder, and is the distance off the end, and then there's a snap ring groove. You saw how the snap ring came out. Have to put a groove in, and I have a tool to do that. Okay, so this one's, oh yeah, there's definitely a difference there. So we're going to make this one that length. How we tell how much to take off, we'll use a digital caliper, not a vernier. We'll measure that. 49 thou. I guess my eyeball is not superb today. Looks good to me. Next step is to bore the inside. You can see how much it's taken off down there. I'm just boring out way inside the tube, and I have to be very careful not to take off too much. So far so good. I don't want it to get stuck. Yes. This is a tricky job. Sweet. That worked pretty good. Okay, so now we'll cut the snap ring groove. Nice. These are the holes that have to be filled up. I'm gonna do some TIG brazing. I'm gonna put a little chamfer. 1, 2. That's pretty quick, isn't it? That's a TIG brazing rod. That's actually very easy to melt in there like that. An oxyacetylene, I'd still be heating it up. Actually, the metal went a little bit hard because I guess the heat came on so fast and then off. It hardened this tubular. I can feel the metal's a little harder on the top. That's okay. How do you clean a file? One of the viewers was asking. Well, this file here needs cleaning. I take a piece of aluminum, just a piece of aluminum, nothing fancy. And if you watch, see how all the little bits come out? That's the best way to clean a file. Because what happens is, as you do this, see, it makes the groove which matches the file perfectly. and it takes out all those little bits. Does not hurt the file. If you use a file card, it's stainless steel, and you're actually wearing out your file. That's what I've been told. So there you go. That was in the file. See all those bits? That came out of the file. Got a piece of metal, 1.125". We need to make a spacer. Actually, 2 spacers is 2.050. I think Mitch had this up on the screen at some point, but those are the spacers we're going to make. So I'm going to go over the bandsaw. I'll cut it off quick, and then we'll be making spacers. That worked out well, so now we just have to do washing and then assembly of the forks. That's exciting. Got my extra long toothbrush here. Oh, that's what was down there. There's an O-ring down there. Found an O-ring. So this is what I use to clean the insides of tubes. Seems to work pretty well. Everything has to be clean, and then we assemble. There's the spacer. Those are the spacers we made on the lathe. Got the valve. Spacer. Okay, it doesn't go like that. This goes in, this goes inside. Like that. And that goes down like that. Okay, so we're going to put this in, we're going to put the circlip in, and then we'll slide this down. There we go. That's what it's supposed to look like. I made up these spaces. These are made out of Delrin. It's black Delrin, and it takes the place of the second seal. You don't need a second seal. A little bit of white lithium. Not much, just a little bit. So this should just fall in basically. There. See how that's a nice fit. On an oil seal, it's good to put a little bit of grease in the seal. It gives a little bit of lubrication. You don't want to put them in just dry. That's not good practice. I have brand new dust caps. These were $52 off eBay or something like that, online. But they're nice and they're going to look good. Okay. I'm sure there'll be some comments about what I'm doing. I'm just kind of self-taught here. Okay, it's at the bottom. And so what the O-ring does, when the forks hit the bottom, when they bottom out, it softens that. It doesn't have that clunk. That's what the O-ring's for. There we go. It's got 4.5 inches of travel. That's what it's supposed to be. That's good. That worked out well. Oh yeah, look at that. Way too long. Okay, we have to shorten the spring. So that's where that goes to. This one here goes to right there. See how it pops down just a little bit? This is kind of a fun job, if you get it right. Okay, that'll work. It's not perfect, but you'll get it down a little bit more here. Okay, see, over here it's touching. Okay, so see how it comes almost to the end? So it's about an inch of preload, and that can always get adjusted later. I've got a new engine plate for the right side. I went to Metal Mart and I ordered a piece of metal, and I went there and they wouldn't charge me. Very nice of them. Thank you, Metal Mart. I get all my stuff from Metal Mart. So that's where the carb comes out, and the velocity stack. It comes out right here. I made a nice fat stainless washer, carved that out of plate, and that worked really well. See, it's the same size. Everything's just right. We hope you liked all the fork mods we did today, and next week we'll do something else on the Aramaki. Thanks for tuning in. Mitch and I like coffee. If you buy us a coffee, we'd like that. Take care. Stay safe. Bye.